Good Fabric applications begin with a data model that makes state trustworthy and usable. In this module, we'll connect ledger records, asset ownership, indexes, queries, and off-chain data, so applications remain performant, auditable, and maintainable as they scale. So far, we've built the foundation: Fabric networks, transaction flow, confidentiality, and Chaincode logic. Now we turn to the data that logic depends on, because the way state is modeled has a direct impact on trust, scalability, and usability. A Fabric data model has to serve two different audiences. Chaincode needs a precise structure for executing transactions and updating world state deterministically. The enterprise needs that same data for reporting, analytics, audit, and integration. That means modeling assets, participants, relationships, and state transitions around the business workflow. If the model is shaped only for storage convenience, the result can be slow queries, weak history, compliance gaps, and painful upgrades later. Fabric maintains two views of the same business data. The ledger is the permanent audit trail. Every validated transaction, ordered into blocks, appended, and never rewritten. The world state is the working snapshot, the latest value for each key, optimized for fast reads by Chaincode. LevelDB provides simple key value storage, while CouchDB adds richer JSON queries. Use the ledger when you need history. Use world state when you need the current truth. In Fabric, an asset is more than a record. It has a stable identity, an owner, a status, timestamps, and version details. The key design choice is to treat changes as named transitions, not casual field edits. Chaincode can then enforce rules for who may approve, transfer, dispatch, or settle. That makes the lifecycle clear for applications and gives auditors a meaningful history of what happened and why. Fabric World State is a key value store, not a relational database first. Strong key design makes access simple and predictable. Use clear prefixes like asset, org, or shipment to group records. For relationship lookup, encode dimensions into a composite key, such as asset owner status with owner ID, status, and asset ID. Partial composite key queries can then find all assets for one owner or status efficiently. Remember though, keys are visible metadata, so do not embed sensitive business information unless your privacy design allows it. Model world state around how the network actually uses it. Store the data needed for transaction validation, shared business state, or trusted coordination, not every detail from source systems. Include identifiers, ownership, status, timestamps, and a schema version so contracts can evolve safely. Keep JSON predictable and query-friendly. Deep nesting and oversized documents may look flexible, but they make validation, indexing, confidentiality, and future updates harder. CouchDB extends Fabric beyond simple key lookups. Because world state is stored as JSON, applications can query fields such as owner, asset type, status, or dates, especially when secondary indexes support those fields. The trade-off is discipline. Inconsistent names, mixed types, or unplanned fields make selectors ambiguous and indexes slower. Model documents around real access patterns while still keeping strong keys for primary lookups. In production, CouchDB performance should be designed before deployment. Define indexes under meta-inf stated B, CouchDB indexes, and build them around the questions your application asks most often: owner plus status, type plus date, category plus location. Then monitor query plans and latency. A rich query without a selective index can become a full database scan. For critical transaction paths, prefer direct key reads or composite key range queries because they remain predictable under load. Rich queries are useful for finding records, but they are not a safe foundation for critical validation. During simulation, a query may return one set of results. By commit time, another transaction may have added matching data, creating a phantom read. Fabric does not protect that query result the same way it protects explicit key reads. For uniqueness, reservations, and authorization, use composite keys or dedicated constraint records. Reserve rich queries for search, reporting, and dashboards. A strong Fabric design is selective about what becomes shared ledger data. Put on-chain the facts every organization must agree on: status, ownership, approvals, and audit checkpoints. Keep large documents, personal information, and volatile operational data in controlled off-chain repositories. When you need proof without exposure, store a hash, metadata, or reference on-chain. The goal is trust and verification without sacrificing privacy, compliance, or performance. One common pattern is to keep large or sensitive documents off-chain and write only a SHA-256 hash plus metadata to Fabric, type, issuer, timestamp, URI, and version. The document remains in a CMS, object store, or content address system, protected by enterprise identity, authorization, encryption, and retention controls. Later, a permitted user retrieves the file, hashes it again, and compares it to Fabric. Matching hashes confirm integrity. Mismatches reveal change or replacement. Privacy in Fabric is not only about hiding values. The model itself can disclose information. Public keys may reveal customers, assets, or transaction volume. Hashes can be correlated when values are predictable. Collection membership can expose who is involved in a deal. Treat privacy as a design review. Keep sensitive fields out of public state. Use private data collections deliberately. Minimize what you store, and plan for retention, deletion, and regulatory obligations from the start. Fabric gives you an immutable ledger, but audit value comes from the model built around each change. A lifecycle event such as certificate issued, transferred, verified, or revoked should record the actor, organization, timestamp, reason, prior status, new status, and evidence hash. Use transaction names and events that express business intent. Then history queries, including get history for key when appropriate, can answer the real compliance questions. Who changed what, when, why, and under whose authority? Fabric applications depend on disciplined data modeling. Represent assets, ownership, lifecycle, and transitions clearly. Use indexes and rich queries for discovery, deterministic keys for validation, and off-chain storage for sensitive or bulky data. These patterns support auditability and prepare the application for endorsement policies, access control, SDKs, events, and enterprise integration.